Okay, good morning students. So we discussed in a last class, so that is topic is the mechanical properties of solids. So mechanical properties of a solids, and so what is the stress and three types of the stress, what is the strain, three types of the strain, and what is the modulus and the three types of modulus, and what is the strain energy. The strain energy produced in the wire U is equal of stress into strain, we find out in the last class. So today discuss some problems. A copper wire, first problem. A copper wire, 1 mm diameter, 1 mm, mm means millimeter, 1 mm diameter is stretched by applying force of 10 newtons. Find the stress in the wire. Stress in the wire. You got it. So a copper wire of a 1 mm diameter is stretched by applying force of a 10 newtons, and find the stress in the wire. Find the stress. Okay, according to the given information, so the copper wire 1 mm diameter. Okay, so the diameter is equal 1 mm and radius is equal d by 2. So 1 by 2 is equal to 0.5 meters. Okay, got it. So the millimeters is also, that means so is equal 1 mm, 1 into 10 to the power of 4 minus 3 meters. We got it. So 1 by 2, so d by 2, so that is called as a so 0.5 into 10 to the power of minus 3 meters. And also the applying force. So applying force, it is equal 10 newtons. 10 newtons force applying on the stretched by a body. Find the stress. So stress S is equal F by A. Okay, stress S is equal F by A. F is the applying force for unit area is called as a stress. So F by A is equal pi r square. So F is equal 10 newtons. So pi is equal 22 by 7 into R. R is equal, so 0.5, or we can write also 1 by 2 into 10 to the power of 4 minus 3. Okay, so 1 by 2 into 10 to the power of 4 minus 3. Okay, so here given 7, 2 jar 14. So 14 is go to up to, we can write 140 by, so here square. Okay, so remaining 22 are cancelled, that is equal as 11. So 11 into 10 to the power of minus 3 minus 6. Okay, so stress S is equal 140 by, here given 1 by 2 square. So 1 by 2 square means 1 by 4. So 1, 2 is 7, 2 is 14. So 140. So remaining 2 is cancelled, 11. Okay, so 140 by 11 into 10 to the power of 4 plus 6 we can write. So 11 into 140. So 11 1 11 30. So 22 8 point 77 3 except is taken. Okay, so that is called as a 12.7, or we can write, so 1.27 into 10 to the power of 4 plus 5 is taken. So this is called as a stress. Okay, so stress Newton per meter square. Oh, we got it. 1.2 so the point is good outside, so we can write the plus 7. Okay. A tungsten wire of a length a tungsten wire of a length 20 centimeters is stretched by 0.1 centimeters. Find the strain on the wire. Okay, so given information we can write. So the length L is equal 20 centimeters. Okay, and also stretched by 0.1. So that is called as stretch delta L. Something change is equal 0.1 centimeters. We can write. So find the strain on the wire. Okay. So strain is equal length by change in the length by original length. Change in the length by original length. Change in the length is taken 0.1 centimeters by L is equal to 20 centimeters. So 0.1. So 1 by 200. Point is there 1. So 200. So that is equal to 0.005. Okay, got it. So 25 is 100. So 0.005. There is no units of the strain. Okay. So strain is equal change in the length by original length. So change in the length by original length. So 1 by 200, that is equal to 0.005. Strain is produced in the wire. If an iron wire, third problem, if an iron wire is stretched by 1%. What is the strain on the wire? What is the strain on the wire? Okay. What is the strain on the wire? So if an iron wire is stretched by 1%, so what is the strain on the wire? Okay, got it. So it is first of all initially the total length. Initial length is taken. So L plus 1% of L. We got it. So L plus, or we can write as a capital L. So L plus 1% of L. Okay, got it. So L plus 1% of L. So that is means so 1% of L. Okay. So 1% L by 100 is taken. Okay. So that is the LCM is taken 100. So 100 L plus L is equal 101 L by 100. So this is what is the total length of the wire. So the initial length L plus 1%. So 1% of L. So percentage means 100. So L by 100. LCM is taken. So 101 L by 100. So the change in the length, first of all, we find out change in the length. change in the length. Change in the length. So change in the length is called, so virgin length is L. So virgin length is 101 L by 100. So minus L. Okay, got it. So LCM is taken 100. So 101 L by 100 L. So L by 100 is called as a change in the length. Okay, got it. So now here, what is the strain? Strain is equal. Change in the length by virgin length. Change in the length L by 100 by virgin length is L. So L are cancelled. So 1 by 100, that is equal 0.01 strain produced. Okay, got it. So this is called as a very important problem, and if everybody is stretched by 1%, what is the strain on the wire? So strain will be produced on the wire 0.01. Okay, there is no units. So next one problem. Take copper wire. Fourth problem. Take copper wire and an aluminium wires have them in the ratio 3:2. Diameter in the ratio 2:3, and the forces are applied, in the ratio 4:5. Find the ratio. Find the ratio of increase in length of the two wires. Length of two wires. Okay. Copper is equal 1.1 10 to the power of 11 Newton meter square, and aluminium. So aluminium, N-mole aluminium 0.7 10 to the power of 11 Newton meter square. Okay. So the copper wire and aluminum wires having the length in a ratio 3:2, diameter in the ratio 2:3, and forces is applied on the ratio in the ratio 4:5. Find the ratio of increasing in the length of the two wires, and N-mole is also given. There is the copper and aluminum. Okay, got it. So now general equation. So we can write so y is equal. Okay, so N-mole is y is equal. So F by A by delta L by N we can write. Okay, delta L by N. So this is called as a N-mole. So F by A, and we can write L by delta L. L by delta L. So that we can write So y is equal to f L pi r square delta L, we can write pi r square delta L. Now given that information, so a copper wire and aluminum wire having the length in the ratio 2:3. So length is equal L1 by L2 is equal 3/2. Okay, got it. L1 by L2 3/2. Or so the copper and aluminum is taken. Okay, so copper and aluminum. So copper and aluminum, and also given the diameter in the ratio diameter. Okay, so the diameter is also here given the radius. So that is called as R copper or aluminum is equal, okay, the ratio 2/3. And so the forces are applied. Copper and aluminum is equal to 4/5. Okay, got it. Now substituting the equation, so gamma that is the Young's modulus y is equal f L by pi r square delta L. Okay, so y1 by y2, here taken the two wires. So Young's modulus y1 by y2 is equal to, they can write. So y1 by y2 is equal f1 by, and that is means so the copper by aluminum is equal, okay, copper by aluminum is equal to, so f copper by f aluminum into L copper by aluminum length. Okay, so into R square means so R aluminum by R copper whole square into delta L. Okay, so the delta L is means given the increasing the length of the two wires, find the ratio of increasing the length of the two wires. So delta L, that is the delta L aluminum by delta L copper is taken. Okay, so y copper by aluminum, Young's modulus. So Young's modulus is given, so the copper by aluminum, so that is called as a 1.1 10 to the power of 11 by, so 0.7 into 10 to the power of 11 is equal f copper by f aluminum. So copper by aluminum 4/5 into, so length is taken, copper by aluminum 3/2. So radius, so the radius is equal to 3/2 whole square. So 3/2 into 3/2. So here given, so the length increasing in the length of aluminum and copper is taken. Okay, so these are cancelled. Point is also cancelled, same in the order. So 11/7 is equal. Okay, so 2 2 are 4, 2 2 are cancelled. Okay, so 3 3 are 9, 9 3 are 27 by 5 2 are 10 into delta aluminum by delta L copper. Okay, got it. So the cross multiplication we get, so delta aluminum by delta L copper is equal to, okay, so 1 10 5 27 7 7 49. So that is called as a 27 7 189. Okay, so 189. So the delta L copper by delta L aluminum is equal to 189 by 110. So this is called as a ratio of the increasing in the length. Ratio of the increasing in the length. So copper and aluminum is equal 189 by 110. Okay, got it. same material, same material, same material, their radius and length are both in the ratio 1:2. If the extension produced are equal, what is the ratio of the loads? What is the ratio of the loads? Okay. Right. So there are two wires of a same material and their radius and lengths are both in the ratio of 1:2. Okay. So the length L1 by L2 is equal. So 1/2. Radius R1 by R2 is equal 1/2. And extension produced are equal. And that means extension means delta L1 by delta L2 are equal. It is the delta L2 are equal. And so find the ratio of the load. Load is means so find the force. F1 is to F2 is equal to M. Okay, find the ratio of the load. Load is means force. Okay, so given information. Right. So the next one. So according to the Young-Morris equation, so y is equal F by A, that is the delta M by L, we can write. So F by A, delta L by L. So L by delta L, we can write. So F L by A is means pi r square delta L. Okay, got it. So here F is equal, so Young-Morris y is equal F L by pi r square delta L. So cross multiplication taken. So Young-Morris y pi r square delta L is equal F L. So F is equal, we can write. So F is equal y pi r square delta L by L. Okay, got it. F is equal y pi r square delta L by L. So having the same length. Okay, that is not the extension are equal. I is a constant. Okay, Young-Morris is the same material, constant. So remaining equation F is equal. Okay, so R square by L. F is equal R square by L. Okay, so if is case of F1 by F2 is equal, F1 by F2 is equal R1 by R2 square into L2 by L1 is given. Okay, got it. So F1 by F2 is equal R1 by R2 is equal. So 1 by 2 whole square into 2 by 1 is taken. Because L1 by L2 is equal 1 by 2. L2 by L1 is taken, that is 2 by 1. So here 2 are cancelled, remaining 1 by 2. Okay, so F1 by F2 is equal 1 by 2. So F1 is F2 is equal, so 1 is to 2. This is called as a load applying on the wire or force applying on the wire. Okay, right. So the next one we discuss some problems. Okay, next class. Okay, thank you students.